This video will explain the past paper questions related to the topic isotopes. Let's look at the first question. The question is saying the naturally occurring bromine has a relative atomic mass of 80 and consists entirely of two isotopes of the relative isotopic mass of 79 and 81. What can be deduced about naturally occurring bromine from this information only? Before we read the option, let's look at the formula that can be used to calculate the relative atomic mass of bromine. Looking at the example, we see that bromine has atomic mass of 79 and the other isotope has atomic mass of 81. The atomic number is same. The percentage abundance of bromine with the atomic mass 79 is 49.7, that is around 50. And percentage abundance means how much of the bromine 79 isotope is present in a cylinder of bromine, or if I am carrying certain quantity of bromine, how much is the bromine 79 or bromine 81 is present in that cylinder. So the percentages of these two isotopes clearly show that they are equally present, like 49.7 is around 50%, 50.3 is around 50%. So this is the formula that we use to calculate the average atomic mass of any element by using its isotopic abundance. Isotopic abundance multiplied by the atomic mass of that element, of that atom, plus the isotopic abundance of the atomic mass of the second isotope. So when we are calculating it and dividing it by 100, we get the answer around 80. So let's get back to our original question now. If we have understood that how we can calculate the average atomic mass by looking at the abundance of the different isotopes of the same element. Now we can read the options and we will better understand this. What can be deduced about naturally occurring bromine from this information only? Alpha option says that bromine isotopes have different number of protons. Now my question is asking me that naturally occurring bromine has a relative atomic mass of 80 and it entirely consists of two isotopes of relative atomic mass of 79 and 81. If it is having two isotopes, 79 is the atomic mass of one isotope and the 81 is the atomic mass of other isotope, and its average comes out to be 80. So what can we deduce from this statement? So we cannot deduce from this statement that they have the different number of protons. So alpha is not a correct option. Bravo says bromine contains the two isotopes in equal proportion. Yes, that is the correct option. That is what we have just justified from the calculation, that when both the isotopes are present in an equal proportion, then the average atomic mass comes out to be 80. If it is one isotope is 79, the other is 81, and if they both are present in an equal proportion, then the average comes out to be 80. So that is the correct option for this question. But let's read the other two options as well. Charlie says bromine has a different oxidation state. No, isotopic abundance or the average atomic mass is not related to the oxidation state anyways. Delta says bromine is a radioactive. No, if we are talking about their average atomic mass or a relative atomic mass, it is not giving us any information about its radioactivity, because the statement is not telling us that this isotope of bromine is emitting any radiation or is it producing any heat. So that is not related to the question anyway. So bravo is our correct option for this question. My next question says the table shows data for the particle W, X, Y and Z. These are the four particles and their proton numbers are given, their nucleon numbers are given, and their number of electrons are given in the last column. So which statements are correct? Let's read the statements. W and X are isotopes of the same element. Now we know that isotopes are the atoms of the same element with the same number of proton but different number of neutrons or different mass number or nucleon number. Now let's see whether W and X are isotopes. W have proton number of 6 and X has a proton number of 6. And their nucleon numbers are different. Like W's nucleon number is 12 and the X1 is 14. So that means they have the same number of protons but different number of neutrons. So that is a correct statement. The second statement is saying Y is in group 5 of the periodic table. Y is in group 5. Group 5 means it must have a 5 electron in its outermost shell, and the distribution of electron is in the first shell we have 2 electrons and in the second we have 7, and Y is having a number of electrons total 7. In the last shell we have 8 electrons, right? Mistakenly I think I have said 7. So in the first shell when we put 2 electrons, then we are left with 5 electrons which will be filled in the last shell. So yes, if it is having 5 electrons in the last shell, that means it is belonging to the group 5. So that is even a correct statement. The third statement is saying Z is a cation. Z can be a cation if it is having less number of electrons than its proton number. But here we clearly see that the proton number of Z is less than that of their electron. So that is not a correct statement. So 1 and 2 is the correct statement. So alpha is the answer for this question. My next question is, a radioactive isotope of carbon has more nucleon than the non-radioactive isotope, which is carbon 612. How many proton, neutron and electron could there be in this radioactive isotope of carbon? Alright, first of all you need to understand or recall the concept of isotopes. Isotopes are having the same proton number but different nucleon number, and in the nucleon number they should be having different neutron number. So carbon 612 means we have to look for another isotope of carbon 612. So it should be carbon 613 or carbon 614. That means it should have a nuclear number of 6 should be the proton number, and it can have a nuclear number of 7 or 8. And here we see that proton number in the Bravo option, we see that it is having a proton number of 6, neutron number of 8 and electron number of 6. So definitely that is the correct option, because in rest of the options we see more proton number in Charlie and Delta, which is not correct of course, and in Alpha all the numbers are same. So that cannot be the answer, because neutron number has to be different for an atom to show the isotopic properties as compared to the given atom. So Bravo is the correct answer for this question. Next question says, a researcher notices that an atom of an element are releasing energy. Why are the atoms releasing energy? Alright, in the topic, in the video where I have explained the topic isotopes, we were studying about the isotopes of carbon, where we see that 2 isotopes are unstable and 1 is stable. So the unstable isotopes mean they are radioactive isotopes. Radioactive elements are those elements which are emitting energy or releasing energy. So why are the atoms releasing energy? That means they must be radioactive, because radioactive isotopes are releasing energy. So Charlie is the correct answer for this question. The next question says, an element X has 2 isotopes, X238 and X235. How does X238 differ from X235? Okay, so these both are isotopes, so they must differ in the number of neutrons. How many neutrons? It clearly says that there is a difference of 3 neutrons. So they are differ in the number of neutrons only, not proton, not electron. So according to this discussion and information, Delta is the correct answer. That says it has 3 more neutrons but no more electron. Okay, the last question of this video says that what is the nucleon number of the isotope of uranium 92-235? You need to know what is a nucleon number. Nucleon number is the sum of number of proton and neutron. It is also called as atomic mass. So in uranium, 235 is the atomic mass. So that means its nucleon number is 235. So Charlie is the correct answer for this question. That's all in this video. I'll catch you in the next video. Thank you. God bless you. Allah Hafiz.